Question 15. You have a magnet, right, going through this coil. So before you even try to figure out what is the induced EMF, you should try to sketch out, right, what is the flux linkage against time. So for this coil, right, you see, as the magnet goes through it, it's always capturing lines, right, which are to the right. Okay, yeah, because whether it's a magnet here or magnet leaving here, the orientation of the magnet, right, is still the same. Okay, so the coil, right, is always capturing the same direction of flux linkage. So that's the key thing. So for this graph, right, you see, as you have the magnet approaches it, the flux linkage, right, it will increase, and as the magnet leaves it, flux linkage will decrease. Yeah, and also because the coil is short relative to the magnet, so right, you have a clear peak here. If the coil is actually very long, so you have a very long coil, sorry, and the magnet is short, then you expect, right, this graph to looks like this. You go up, stay constant for quite a while, then come down. So that's the difference between a long coil or a short coil relative to a magnet. So back to this question. So if you want to find the EMF, right, is equals to d phi dt. Yeah. So it's looking at the gradient of this graph. So at first, right, you have zero gradient, increasing, but all positive. Then after that, second half decrease until the peak. So, and then on the exiting, right, you have negative gradient, steeper, less steep. Okay, so here, right, and here are opposite sign. Yeah, because the gradient is opposite. So you expect the induced EMF, right, to have opposite sign. And you have a 0, 0, 0, okay, correspond to here, and here. And maximum gradient, so maximum, and opposite sign. So the graph, right, will look something like that for B. Okay, it's not necessarily sinusoidal, and doesn't need to be. Okay, but it's generally of this kind of shape. It could also be like this, yeah, which is not sinusoidal. So just look out for this kind of shape, and look out for the fact that here and here are opposite sign. Okay, then that will be good enough.